guys, it's Miss Mart, and I'm here today to demonstrate frequency and pitch. And what we want to know is, how does changing the size of an instrument alter or change the pitch or the way that it sounds? And we remember from our class before that frequency is the number of times that a wave passes through a given point. And the given point for our purposes now is a time period. So if we look up here, remember that a whole frequency wavelength is the top and the bottom. So an example of a low sound or a low pitch would have a really low frequency because they have a direct relationship. So my frequency here is just over 1 wavelength. If I look down at a high sound or a high pitch, my frequency is noticeably higher because I have so many more wavelengths. So I have 1, 2, 3, 4, 5 wavelengths there. So that must be a higher pitch. Now let's check out the water bottles that we've got set up, color coordinated. Lower sounds are going to have more room in the bottle for the air to blow around. Because remember, we said sound is when particles are moving around. So if I have more room, it's going to be a lower sound. If I have less room, like over here, I'm going to have a higher sound because I'm going to have a faster frequency. Okay? All right, so let's check this out. Here's my low sound. Here's a high sound all the way up at the top. And for you musically inclined people, yes, that was an octave. And because I am so into music, I made a scale so that later on we could play a song together. So, if you can guess, if we have low sounds with the least amount of water, if we look at the colors, my sound should get higher. Let's test and see if that works. It's a little bit higher. A little bit. A little bit more. 2 left. Could they get even higher? Excellent. So they all got higher pitches because the air was less. There was less room. The water blocks off the amount of air possible in the bottle. One last question. High or low? Really, really low. Bye.